Hello friends, welcome back to my YouTube channel. So we are discussing resistance of a system of resistors. In our previous class we have discussed the series connection or resistors in series. So today we will discuss the second connection, that is parallel connection. What connection? Parallel connection. Parallel connection. So parallel connection is somewhat like this. So when three resistors will be connected in this way, parallelly, R1 is here, R2 is just below it, and R3 is below to that. Then it is called a parallel connection. You know what are parallel lines? So just like that, R1 and R2 and R3 are connected. So this type of connection in a circuit is called parallel connection. Now, most important part of the parallel connection is that all the resistors are connected across the same two ends of the wire. If this is A, this is B. So, what will be the potential difference between A and B? That will be the potential difference of all the three resistors, across all the three resistors. So, here V will be same. Earlier we had current was same across the resistor in series. We saw I is same, but in parallel V will be same. Okay? Now let us complete the circuit. Suppose this is the battery and this is the circuit. You can also give a key here if you like. Now whatever current will flow for the circuit at this junction where the wires meet together, where many wires meet together, the point is called junction. Mind it. We will get these things in class 12. Current. So at the junction, current will now have three ways to go, and current will obviously flow from all the three ways. Let us say through each way, or current from R1 is I1, because I1 will flow like this. I2 will be the current through the resistor R2, and I3 is the current through the resistor R3. So using the Ohm's law, V equal to IR, what we can write? V equal to IR1 for the first resistor. For the second resistor also potential is same, so it will be again V equal to, here it will be I1 because current will be different, I1, I2 and I3. I1 R1 for resistor R1, for resistor R2, I2 R2, and for the resistor R3 the potential will be same. So equation will be V equal to I3 R3. We get these three equations. Now when we replace this circuit with a simple one having only one resistance or one resistor, which is ultimately the combination of these three resistors, then here it will be the total resistance of the three resistors. Potential difference will be same because we have just replaced the resistor. No other changes are made. So current also will be I. So here what you can write? Here you can write V equal to IR. Now have a look at these three equations. From here, what you can write? I1 equal to V by R1, I2 equal to V by R2, and I3 equal to V by R3. Now have a look at this situation. This current I gets divided into three parts and gets equally divided as I1, I2 or I3 and I3. It may not be equal, that's something different, but it gets three equal divisions. So we know I will be equal to I1 plus I2 plus I3. It gets three division. The same current I gets divided. So the amount of current coming from here only will be the sum of the three currents. So from that fact we can write this equation. Now just put the values of I1, I2 and I3. I equal to I1 means V by R1, I2 means V by R2 and I3 means V by R3. What is I from here? I is V by R. So V by R equal to V by R1. In fact, you can take V common. So 1 by R1 plus 1 by R2 plus 1 by R3. So V and V will get cancelled, and finally what we will get? Let me rub this off. Finally we will get this V and this V gets cancelled. Finally 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. This will be the equivalent resistance in case of a parallel connection. Please note it. So am I clear? Now, in the series connection we have seen, what we have seen? We have seen that in series we get maximum possible resistance, but in parallel we will get minimum resistance possible for the same set of resistors. So let us take the same example that we have taken in our previous class. You were given 3 ohm, 4 ohm, 5 ohm and asked what is the minimum possible resistance. So what will be your answer? It will be simple. That for minimum resistance we have to connect these three resistances in parallel, and for parallel connection we know 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So here what will be the final resistance? We don't know. We have to find out 1 by R. 1 by, obviously R1 will be 3, R2 will be 4, R3 will be 5. So from here you can take LCM. Let us solve it. Three, 4, 5, 3, 4 is 12, 12, 5 is 60 will be the LCM. 1 by R equal to 60, 3, 20 is 60, 20 plus 4, 4 1s are 4, 3, 4 5 are 4, 15 are, and 5, 1 are 5, 12 are. So this is what 1 by R is. So 1 by R equal to 20, 15 and 12, 7, 47. 47 by 60. So R will be 60 by 47. So this is the minimum possible resistance. And what is the maximum? For same three resistors, it will be the series connection, it will be in series connection, and that will be 3 plus 4 plus 5 equal to 12. So this is the maximum. So the most important thing in this part is that for maximum resistance we have to connect them in series, and for minimum resistance we have to connect them in parallel. And all other connections, the resultant resistance will be in between the maximum and minimum resistance. We will discuss this in details. Also we have very interesting questions like two will be connected in parallel, then with this one will be connected in series, and as a whole this will be connected again in parallel, and then it will be connected with the battery. So how to find R equivalent of such type of circuits, we will discuss in our next class. For that, till then you can try this. Suppose this is a circuit. Now here you have to find out the R equivalent. Suppose its resistance is 1 ohm. 1 ohm. So here you find out what will be the R equivalent of the circuit. This is a homework question. We will solve it in our next class. So thank you. Regarding any doubts, you can contact me or mail me here. Thank you.